In this video, I'm going to show you how to solve this problem caused by I4 telling Q2 to go backward. I4 is connected to Q2 so that Q2 could go backward. So it creates a problem because I4 is constantly pressed at the moment. Therefore, a signal at I4 is being released for Q2 to start. So let's draw up that so that we can try to solve the problem. So now, put your first latch, connect to your first motor, and I2 will be activated there, and it will switch off the motor from going forward, and then motor, the output for downward motion will take place, and then as it takes place, it will be stopped by I3 there. I4 will then be released for the first time, and then I3 will then have a chance to be pressed. While it gets pressed, it prevents the motor from obviously crushing the items. So now I3 will then release an upward motion that will be stopped by I4, and I4 must release the motor to go backward until I1. To avoid these lines from confusing you, you need to always separate them. When they are in line, you will regret always. They don't need to be in line. They need to be separated so that you can read them. Alright, on the next step, we test this preliminary drawing of ours. I4 is on. Immediately, motor 2 goes back immediately, which is a problem. When you press I1, when you put an item there at I1, motor forward and backward, they are both activated, and we don't want that. We need a system where I4 would not be able to activate backward motion without something taking place. So, to be precise, we would say I4 must not activate this latch before something is being activated, and that thing is I3. Remember, at I2 here, this creates a downward motion. The puncher will go down and it will release I4. Then after that, I3 will be pressed. Then it will go to I4. So if I3 on that moment, while it is being pressed, it could create a system like this. It could latch. It will preliminarily latch the end on one side. Then when it gets to I4, then I4 signal combined with the one from the latch will enable the motor to go back, and it is very vital to reset that latch. I prefer resetting it using I1 because it's far away from the whole mess that is happening here. Alright, so now I want to test the system. I4 is on currently, I1 switch is on. You see, the backward motion is not affected, only the forward. Okay, it will go and release here, and when it gets to I2 will create a downward motion. As downward motion is activated, I4 automatically is released. And then when I3 is activated, I2 is still activated. Keep that in mind. I2 is still activated and it wants the downward motion to take place because the part is physically there at I2. Therefore, it will constantly demand the downward motion. The similar procedure or problem as we experienced with I4. So we're going to prevent it now. Imagine the process can take place smoothly. Then I3 would be able to let our system go up. I3 will let our system go up. You see now we have a glitch there. Motor down, motor up, they're both on. But that is not a problem. I want to show you what happened to the latch here. The latch is on. So should the upward motor successfully reach, as it goes up, if it should successfully reach I4, it means that I4 would be able to switch on the motor to go forward. But let's not forget that we have this problem. The I2 is calling the motor to come down and I3 is making the motor to go up. We are having a minor problem there. I'm going to enlarge my screen so that I can show you how I can solve this problem. Alright, for more visibility. Alright, so now I2 it's pressed permanently in short. For as long as the item is at signal I2, it will always tell the motor to go down. To prevent that, you can use an AND edge, which only releases one signal at the time. So with this one, you connect it anywhere, then you connect it there. For as long as I2 is pressed, the signal here will only come once and it won't affect the downward motion to keep on wanting the motor to spin downward. So let us test this solution now. Alright, I4 is pressed, we know that, and then I1, when we press I1, the item starts to move. As it moves away from the sensor switches off. But the motor is still active, as you can see even here. When it reaches I2, look at this. Motor 1 switches off. And then I2, the downward motion takes place. Remember, as it goes down, I4 gets deactivated. When it reaches I3 deactivates the downward motion and activates the upward motion and activates the preliminary latching here. That in short will enable I4 to set the backward motion. So look right now, when the puncher goes up, it will reach to I4. But first it will start releasing I3 there, and then goes up. Look at this, it's still going up. It goes up to 4. Look now, it has reached 4. 4 is permanently pressed, and 4 resets the upward motion. If the upward motion is not resetted, it will go up outside the roof. So we don't want that. The machine will go up constantly. So I4 resets the upward motion. Then I4, with the power invested in I3, it was able to let the machine go back until I3. And as it starts to go back, remember that, as it starts to go back, I2 becomes depressed, and then it goes until I1. Then when it gets to I1 will return the what you call this? I1 will return the forward motion again. So obviously we don't want it to constantly going back and forth. Therefore, you can put a delay here of around 5 seconds to prevent it going backward immediately after it gets delivered to you. So now put a delay there. Not necessarily a delay, but in most cases you can't start a machine with a sensor. That is a risky business. You need to be able to start it with a push button separately and an emergency push button, so that you can control any problems that can occur in the process. You can stop at any time. So this one is just to show you the schematic of what happens within the machine, and should you need to really use it in a machine, you would definitely require an external push button. As you can see on this picture, there is no any push button, but once you are wiring it, you need to add the push button. The 2 push buttons, the one for starting, the one for emergency stopping. It is very important. So now we have placed that delay. So you see the delay is counting. It enables you to move items as they return back. So let me practically demonstrate that. So now the forward motor is on. It goes until I2, and then I2 switches it off. Then the downward motion takes place. As it takes place, we need to remember that I4 would be disengaged, and then when it reaches I3, then I3 allows the puncher to punch the item and goes up after that, and it preliminary latches for I4 to be ready to go back. I3 will be deactivated. Then at I4, which will the system or the puncher will remain at I4, the motor will go back. As it goes back, it releases the item. As it gets to I1, you are able now to take the item, then I1 will be deactivated until you put another item again.